Okay, so this is piecewise and step functions. We're going to start with piecewise functions. Piecewise functions is a function, zoom in, written using two or more expressions. So it's going to be two or more lines, but there's more to it than that. Right here it says graph this function, and it says x is less than -1, x is greater than or equal to -1. Just like when you're graphing an inequality on a line, this right here where it doesn't have the line under it is going to be an open dot, and then with the line under it, it's going to be a closed dot, so just make a note of that. Okay, so right here we have x minus 2. That is y equals x minus 2. So the line we're going to graph is going to be this one. And then using another color, if you want to try to match my colors, that's fine. Using another color, this one is going to be y equals x plus 3. So 2 different lines there. But what we're going to graph, this x has to be less than -1. So up on here for the orange, so match your color, whatever color you used here, match it up here. X is less than -1. So I'm making this note that this line has to be less than -1. And then here x is greater than or equal to -1. So my blue is going to be all these numbers over here. Greater than or equal to -1. Yes?
Why did you do y equals x minus 2?
Well, because it has these two, like f of x equals x minus 2 and f of x equals x plus 3. I wrote it this way so it would be easier. Like, you can see how to graph it when we get there. Okay, so now we are going to graph our lines. Now's when you want to use your pencil that you can erase, because you're going to erase part of the line that's not in the right section. So using our pencil that we can erase, we're going to graph this line. The y-intercept is at -2. And then the slope is 1. So I'm going to go up 1 over 1, up 1 over 1. I realize a lot of this isn't even in the section that I need. Remember with slope, you can also go down 1 over 1, like this. And then, using your straight edge, you might want to use your ID. I'm going to graph this line ever so lightly because part of it's going to get erased. So graphing that line very lightly. Now what? Well, the part that is valid has to be less than -1, x less than -1. So on -1 right here, I need an open dot right here. Open dot because we don't have that line under it. And then it's going to go all the way down here. So this orange line is from -1. The slopes is 1.
Well, yeah, I'm talking like the actual coordinate that you circled.
Oh, yeah, the actual coordinate is at, yeah, -1, -3. Yes. Yes.
Why did you say that the slope's 1?
In front of the x. Like,
Oh.
there's nothing there, so the slope's 1.
Why did you plot it there?
What's that? Why did I put the circle there, or why did I plot the line there?
Like, why did you put the circle there?
Because x is less than or equal to -1. So at that -1, that's where my line is, and I put an open dot. And then I'm going to erase everything that's above that. So once I identify where that point is, I'm erasing all of this because it's like not valid. It's not part of it.
You just put the line in like a random part of the graph. Like, could you put it somewhere else? Never mind. -2.
Okay, for the next one, we're going to do the same thing. We're going to plot the line and then erase the parts that aren't in like the blue section. So y-intercept is at 3. 1, 2, 3. And then our slope is just 1, so up 1 over 1, up 1 over 1. And go down 1 to the left 1 as well. Then I am graphing my line very lightly because I'm going to have to erase part of it. And x has to be equal to or greater than -1. So at -1, I'm doing a solid dot, closed dot, and then it's for all the x values greater than -1. So it goes this way.
Why did you place the closed dot there?
Because x has to be greater than or equal to -1. So I put the closed dot where the line hit -1 for x. Yes.
This is a stupid question. How do you like know which direction to go?
For
Like the arrow.
up here or here.
Both, I guess.
Well, this one, x was greater than or equal to -1, so it's all the numbers on x greater than -1, so it's this way. And then technically the line goes in both directions. Normally you put arrows on both sides, but because they erased that, like, it's just not there. Okay, then last step is to identify the domain and range. So domain, remember, is your x values, your left to right, and range is your up and down, your y values. So domain is all your left to right. It looks like it goes forever and ever in this direction, and this goes forever and ever in this direction. So for domain, it's just -infinity to +infinity. It's all values of x.
Why did it go negative positive?
Because it goes forever this way to infinity, and then this one goes forever this way to infinity.
Oh.
Okay, and then for range is where it gets a little bit tricky, especially with this one, because as you can see, it goes forever and ever down, and it goes forever and ever up, but it doesn't include these numbers on y. So for like -3 to +2, it doesn't include that. So the way we write that goes -infinity up to 1, 2, 3, so -3. It's an open dot, so we use the parentheses.
Did you get -3?
It's at -3 on the y. And then for this one, this is at +2. It's a closed dot, so we use the bracket. And then it goes up forever and ever, so that goes to infinity and beyond. Like I said, we're practicing this for 2 days. I know it's a lot of steps, so just go with it. Ready for the next one? Next! Okay, this one's same idea, except for now we have 3 functions. So we need 3 colors. The 3 colors I'm going to use are like this reddish, pink, purple, and green. If you want to try to match my colors, that's up to you. Okay, so this is going to be my... Oh, I lied. That's for the next one. Sorry. Why did you get it out? I'm doing these 3. I'm ahead of myself. Blue. This one's going to be our blue. This is going to be orange. And this is going to be purple. So for blue, we're going to have y equals 3x minus 2. For orange, y equals 4. And for purple, y equals 2x plus 1. Now we have to identify which sections for what. There is a typo actually on this worksheet. This should be -2, and this should be -2. Okay, so for blue, x is less than -2. So anything less than -2. And for orange, it's from -2 to 2. And then for purple, x is greater than 2. Here's our sections.
How did you get orange?
-2 to 2.
The one on the right is, what color is that?
Purple. Yes.
Shouldn't the purple be like intercepting the orange?
What do you mean?
Not really.
They're on the same point. Same color.
It's supposed to be on 2.
Doesn't he say x is less than -2? Or, wait,
Dun.
never mind.
It's okay. It's cool.
It's because I drew it in wrong with the different colors.
I'm struggling.
Okay. So we're gonna start with the blue. I'm going to do it in my super erasable pencil because I'm gonna have to erase a lot of the line that I draw. Our y-intercept is at -2. And then the slope is 3. So that means up 3 over 1, up 3 over 1. But as you might notice, we're going to have to erase a lot of that line over here. So I'm also going to go down 3 over 1, down 3 over 1.
This is for blue?
Yes.
It,
Yeah. It doesn't fit the graph very well. So I'm lightly drawing this line. And then for blue, it's x is less than -2. So I'm going to find -2, find the point. It's going to be an open dot. And then I'm going to erase everything else.
this is blue.
Yes, this is blue.
For the part that you circled, do you find that point that's on the line you plotted? Like, for this, it was
-2. So I just looked at where it intersected that line that I drew. Yeah. Yep. Now, orange looks weird. It's just y equals 4. Y equals 4, 1, 2, 3, 4 would be right here. And it's just from -2 to +2. So it would be a closed dot here and a closed dot here. And it would be just a straight line in between those two closed dots.
Would you not put a point on y equals 4? Like,
Well, technically it's all points on what, so. Notice that when there is a closed dot on, let's say, -2, there's only one closed dot and the other one's open. Because remember with a function, you can only have like one point on that spot.
That's just more steps.
I'm just pointing that out because it comes up later. And then for purple, you have to graph that line. Y-intercept is 1, and then the slope is 2. So up 2/1. I'm doing it with my erasable pencil because I'm going to have to erase some of the line. Then for the purple, it is x is greater than 2 and it's an open dot. So at x equals 2, do an open dot, and then continue my purple line upwards. And erase everything else.
Where'd you put the open dot?
At 2. X equals 2.
Is that because it says it in the problem?
What's that? That's where it intersected the line, like when I drew it out. Like when I drew, so my y-intercept was 1. I went up 2/2, up 2/2. I had this whole line drawn. And then x has to be greater than 2, so I did an open dot at 2. There we go. And then next is domain and range. Domain is your x values from left to right, and then range is the up and down. Okay, so domain is our x's. This goes on and on in this direction. This covers these 4 points, and then this goes on and on in the other direction. So our domain is just -infinity to infinity again.
What usually be -infinity to infinity?
For a function, yeah.
Why was it
Unless-
parentheses?
Because remember with the infinity signs, we always use the parentheses. And then range is where it gets tricky because we have these down values. We're missing this whole part of the graph. And then we're actually missing in between 4 and 5, if you can see that. So when we do range, it looks kind of weird. Range, it goes down forever, so that's -infinity. Up until this point in the y, which is at 1, 2, 3, 4, 5, 6, 7, 8. That's at -8. It's an open dot, so it's parentheses. Who dat?
And then -infinity was because it goes down forever, the bottom one.
Yes. I feel bad that you missed this, Mason. Okay, so we got this part. Now we have to account for that part's missing, and then we have 4. So for this, it's actually just 4 bracket, because it's closed dots at 4. And that's it. And then here, we're at y equals 1, 2, 3, 4, 5. It's going to be 5 to infinity and beyond.
How'd you get 4?
For this, for her. Okay. Now we're working backwards. It says write a piecewise function, piecewise defined function. It gives us the lines, and we have to write out all of this stuff. Oh wait, sorry. We're writing out all of this stuff based on the graph. So working backwards. Here we go. Is this making you feel like super smart? Or the opposite? The opposite. Okay. Okay, so f of x, and we have these like parentheses things. We're gonna have like 3 equations of the line, and then we're gonna have x is like less than or equal to, like that. Now, I'm going to color code my graph, so kind of working backwards. There's 3 parts of the line, so this is going to be our red section. This is going to be our purple section, and purple is just this, it's just literally from 1 to 2. And then this line will be our green section. This is from 2 up.
How did you do the arrows?
Which ones? These?
Yeah.
Well, for each section, I have my purple section, and then my green section will go forever this way. Then, like labeling these sections for this part. For my red section, x would be less than 1. Less than or equal to 1. Do you have the packet, Pat?
Yeah, I got
You do? Okay. Well, at least you have that. You're probably totally lost. We're spending another day on this tomorrow, so.
Alright.
Yep. Now for the purple section, it's from 1 to 2. Something I want to make a note of that was in the answer key is that for this, it's like x is greater than 1 and x is less than 2. Even though it has a closed dot, they didn't put the line under it. Yes.
That was actually my question. Like, how can you tell if it's like greater than or greater than equal to without the line?
Oh, without the line or with the line?
Without the dot. Like, it's close enough.
Yeah, I honestly, when I taught it this morning, I put a line under it because it's a closed dot, but there can't be.
Like, is there any other way to find out besides just a dot? If you're looking at it.
I don't know. I think the reason why in the answer key it didn't have the line is because for every x there can only be one y, but in this case it's the same. So whether you're graphing this line or this line, you'd still get the same output. So I don't know. I feel like I just want to put a line. And then for green, it's 2 and up. So x is greater than 2. Greater than or equal to 2, because closed dot. Okay, so we got this part figured out. Now we just need equations for each line. For the red one, it's fairly easy. You have your y-intercept is 3, so y equals, and then we just need the slope of this line, which is going up 1 over 1 or down 1 over 1. The slope is 1, so it'd just be 1x or x. Oh, I didn't realize you couldn't see that. Here, let me zoom out. So I just wrote this. Our y-intercept is 3. Our slope is going up 1 over 1 or down 1 over 1. The slope is 1. So here we just put x plus 3.
Should it just be x plus 3, or should we have to write f1x?
You don't have to write 1. I just did that to show the slope is 1. And then I'm skipping purple because that takes an extra step. For green, you can't see the y-intercept unless you like extend it out. And then you see that the y-intercept is -4. And then we can use that to write our green equation. The slope of this is up 1 over 1, up 1 over 1. It's just 1, so it's x. And then the y-intercept is -4. So this one is x minus 4. Technically, this part of the line isn't drawn. I just drew it so I could find that y-intercept.
What about purple?
Purple, we're going to have to solve for it, like big kids. Yeah. Okay, so for purple, you'll notice that you'd have to like extend this line out a lot to find that y-intercept. So we're going to actually solve for it. So we need the slope, and we need a point on that line, and then we can use y minus y1 equals m times x minus x1, the point slope form, to figure out what our equation of the line is. So slope of this line would be 1, 2, 3, 4, 5, up 6 over 1, so it'd be 6 over -1, or just -6 is our slope. And then we need a point on this line. I'm going to choose 1, 4.
Why is that other 6 circled?
Because I wrote it this way at first, 6 over -1, and then I just simplified it to -6. So that's our slope.
Oh, gotcha.
Yeah. So our slope's -6, a point on the line is 1, 4, and then we can use this point slope equation to find the y equals mx plus b format. Yes.
How did you get the slope as -6?
So from this point to this point, I went up 6 to the left 1, or -1. So 6 over -1 is -6.
Oh,
And then from here, I'm plugging these numbers into here. So y minus our y.
Is that another y or is that -4?
Y minus y1. So
No,
this is,
underneath it.
oh, y minus 4. Yeah. Then getting y by itself. And I get this, -6x plus 10. So that is purple. So, like I mentioned, you don't have a homework assignment on this tonight. We're going to practice it more tomorrow before I give you like an independent assignment on this. We're moving on to the next page. 16 minutes. Actually, I'm gonna
Oh, what was the fill in?